Above, below, before, behind. Above, below, before, behind.
Above,
below, before, behind.
above, below, before, behind.
Shall we continue?
From the right and from the left.
Shall we continue?
We hear from above, below, before, behind, from the right and from the left, and from all points. How do we become acquainted with the direction from whence sounds reach us? This is a question which everyone who has investigated the economy of the ear has been unable to answer, even plausibly, for all that has hitherto been said on the subject is equally unscientific and uninteresting. This is a quote from David Todd in 1832, taken from a new book called Stereophonica. Hello and welcome to The Rest is Just Noise, a monthly podcast all about the science, beauty, and noise of our cities. I'm Andrew. I'm an acoustician and a soundscape researcher, joined by my co-hosts.
I'm Francisco. I'm an architect and a soundscape researcher.
I'm Tin. I'm an architect and an urban planner and a soundscape researcher.
Today, we're speaking with Gascia Ouzounian, professor of music at University of Oxford, about her book. In it, she traces the development of this spatial understanding of sound from its modern birth through science, war, music, and finally, to our cities.
Shall we continue?
It's a very good one.
Behind. Above, below.
Do you see my eyes wandering?
The rest is just noise.
From the right and from the left.
So thank you very much for joining us, Gascia.
Thank you so much for having me. It's a pleasure to be here.
Brilliant. So, as I said, we're going to dig into some of your book. We're going to go through a couple of chapters of it and trace how spatial sound and the understanding of our relationship to it has sort of evolved since this sort of original birth of it in the modern age. But let's start with a little bit on you.
Sure.
What do you do in acoustics? How did you get into it?
Yeah, it's interesting. Even the question of being in acoustics. I would describe myself as, I came into this world first actually as a classically trained musician, as a violinist, and I studied also music technologies, both for my undergraduate, which was at McGill University, and there they had quite a rigorous program. It was called Computer Applications in Music, and we took courses in acoustics, physics, maths, computer science, which I found quite tough because you were competing with other students for grades, and they were the kind of more experts, and as well music tech. And then I did a PhD in a program called Critical Studies and Experimental Practices at UCSD. I was very interested in experimental music, contemporary music as a violinist at the time, and kind of more of a practitioner. And during my PhD, I was doing a study on the history of sound installation art, which is really kind of expanded forms of sound sculpture, which immediately raises questions about sound in connection to space and how sounds are kind of, how artists approach that, let's say creating sonic spaces. And so then there's a question about how do you analyze these kinds of works, especially coming from music, where you're really normally doing an analysis of, sound in relation to time. And that then led me to ask this question, people use these words like spatial sound. What do they mean? Or spatialization, where do these ideas come from? It seemed like there were quite different, interests, let's say, bearing on some of those terms, and they've evolved over time. And that led me to writing this book, in which I wanted to do a historical study tracing some of these developments in the sciences, in the arts, sometimes in industry. Also, there's, as you said, important moments in the history of warfare as well, and to show their interlinking connections.
And you sort of start out the introduction of the book by kind of making this statement that we hadn't really thought about, in a scientific way, thought about the spatiality of sound as much. And that was sort of a development that had to come in?
Yeah. Let's say there were, I guess even before that idea of science, there were, people doing things in natural philosophy, let's say within Western cultures. And they were, of course, thinking about things like echoes.
Yeah.
And I allude to that in that first chapter. I tried to kind of look at that too. And it also has different spiritual and, religious resonances. And it's not only in relation to the physical, but I was interested in that moment in which that concept of binaural audition starts to become rigorously, systematically, scientifically studied, let's say using the scientific method. And that doesn't really happen until the 1850s, 60s, 70s. There are a few experiments before that.
Yeah.
But yeah, and then how do people, develop an understanding of binaural audition, whereas in Western medicine and science, it was really usually monaural audition that was treated in scientific texts.
They'd sort of only been thinking about it in terms of like a single ear and assuming that I guess you kind of just double it up and that's the same thing, right?
Exactly.
And so you sort of connect it back to the development of binocular vision, the science around that sort of stuff. How did it sort of come out of that? Was it the same people working on it, or
sometimes it was the same people, and if not the same people, they were relying on both a language that was developed in relation to a science of binocular vision, as well as scientific methods of testing that sense. So, for example, Charles Wheatstone's studies on the physiology of binocular vision ended up being quite influential for people who were studying binaural audition, and especially his idea of testing, multiple factors entailed in binocular vision at the same time. So how lighting and distance and, space, the interplay of different factors. So not everybody was doing that. Some scientists at the time thought, it's only time or only intensity that matters. But, how does intensity and phase and et cetera, play? So I think they were, for example, drawing on Charles Wheatstone's methods, as well as a language around binocular vision in developing ideas about binaural audition.
Could you tell us, like, thinking about some of those early methods of coming from binocular experiments into binaural experiments, like what were some of the experiments? What were they trying to do? How were they trying to find this out?
Sure. So, for example, Charles Wheatstone had invented the stereoscope, which was a very popular method for viewing images in 3 dimensions. And it was a method of kind of image consumption in the 19th century. And Jonathan Crary writes about that in his book, Techniques of the Observer. So there you're looking through this device, which is allowing you to basically combine 2 identical images, which are, placed at a distance, but you're viewing it as a single 3-dimensional image. Well, that device was a basis for several scientific instruments that were then developed to test binaural audition. For example, the pseudophone, and also Charles Wheatstone's, in that case, pseudoscope. Sorry, I'm getting too confused. There was the homophone and then the pseudophone. And that was also based on another device of Charles Wheatstone's, which was called the pseudoscope, which that device was intended to kind of do illusions, let's say, in visual space perception. So then the person who developed the pseudophone, based on Charles Wheatstone's pseudoscope, was thinking, how can we do that in the oral field? So create a sense of illusion in terms of where sounds are coming from. So the pseudophone was almost like a kind of headphone with metallic reflectors, which would, you could adjust. And so it would kind of change the sense of where a sound was coming from. Whereas the pseudoscope, you would look at different objects through the pseudoscope and see them kind of, you could do kind of different experiments with conversions of relief, visual relief. So in those kinds of cases, it was kind of a direct, mapping out of ideas from the science of visual space perception onto the science of auditory space perception.
So what you were saying with the pseudophone of coming from all these different directions, that sort of gets to the quote that I read at the beginning from David Todd of, above, below, before, behind. Not, when we hear stereo, right? I think most people think, oh, you've got a left channel, right channel. So you have left and right, sort of lateral directions. Were these scientists who were looking at this, were they thinking from the beginning, oh no, we can do up and down direction. We can do all this 360-degree direction. Or were they sort of limited to
I think it went in
stereo-lateral?
stages, but some of their experiments were quite, did start to look at that, other dimensions in terms of directions as well. But first, for example, Alexander Graham Bell, for example, was trying to test stereo audition through listening through the phone. So after he had patented the telephone, he conducted a series of experiments in which he tried to determine, can you hear where sounds are coming from when you listen through the telephone? And in that case, they were using 2 telephone receivers at the same time. And it was a kind of stereo signal. But he was also trying to see, okay, we'll put this person in that room and, with the transmitter and the other with the receiver. And we'll do them with blindfolded 1 receiver, 2 receivers, etc. And at that point, I think it was mostly kind of distance and direction. Could you tell how far away sounds were as well through telephonic listening? Yeah. And, he determined you could not, but he was the person to coin that term stereophonic, based on the Greek term stereos, which means solid, because he said, sounds assume a sense of solidity when they're perceived with 2 ears at the same time, versus through 1 ear.
I'd never known that was where that came from.
That is where that came from, and that was around 1880, and that came out of this series of experiments that he was doing with telephonic listening. But then at the time, they didn't have this term stereo. He proposed that in this article called Experiments in Binaural Audition.
So they had binaural before that?
They had binaural before that, which came from actually studies on auscultation, so listening to the heart using a stethoscope. And the person who coined that term was actually a British physician, Somerville Scott Allison, and he invented this device called the differential stethoscope, and it had 2 listening cups that you would place both on the chest of the patient, and you would listen using a binaural earpiece to the 2 kind of, let's say, signals at the same time. Now, and he also then, had a kind of quasi almost stereo mode of listening with that device. Of course, again, this is an analog device. Yep. So he coined the term binaural actually to talk about the binaural earphones of this binaural stethoscope, but then he invented this other stethoscope, differential stethoscope with 2 listening cups. In any case, that term binaural, once that started to enter the scientific lexicon, starts to become associated with a sense of spatial hearing. And then many scientists are then testing this, especially in the 1880s, 1890s. And
then it's interesting that you said it was Alexander Graham Bell who coined stereo. He associates this binaural listening with a solidity.
Yeah, that's right. That's right, because he's also talking about, again, he's referring sometimes to Charles Wheatstone's work with stereoscopes, and that you are viewing an image in a more 3-dimensional way. So when they say solidity, I think they're talking about dimensionality.
So which came first? Was it stereoscope in vision,
yes,
or was it
stereoscope in vision? Okay. Exactly, and he coins this term stereophonic, actually in relation to vision, and he says that his telephone, he predicts, is going to be used in order to produce stereophonic effects, as with the stereoscope, kind of just as you have, kind of like stereoscopic for the ears.
So. And today we have binaural to depict fancy stereo.
That's right. That's right. Yeah, and then exactly then how we think of kind of binaural today in relation to audio is then does start to become developed in around the 1930s.
So we're actually joined by our new 4th co-host, Oscar.
Oh, hi, Oscar.
Who's our binaural head sitting in the corner over here.
I like having him right there. Yeah.
And so I think, he's named after the first binaural head, which you talk about in your book, who is named Oscar. Could you tell us sort of how the idea for doing that came up? And I guess for listeners who don't know, what in the modern day, what binaural audio is usually conceived of?
Absolutely. So may I rewind for just 1 minute to say,
Sure.
So Alexander Graham Bell proposes that his telephone could be used to reproduce these stereophonic phenomena of audition, of binaural audition, he says. And then actually his telephone is used to create, let's say, the first stereo transmission system, which is the theatrophone, which is then developed in 1881, which is a device to do stereo broadcasts from theaters and plays and opera and music to people who held 2 telephone receivers to their ears. There was kind of almost like a microphone array, but with telephone transmitters at the foot of a stage, and one side went to the left channel, one side went to the right channel. That was in 1881.
Probably with less delay than over the internet.
Probably with less delay.
No
That's right. They were doing it over telephone lines.
Yeah. So it was like
and
direct, like physically connected. between the 2 things. Yeah.
That's right. And, people were very astonished when they had this experience of stereophonic audition. It was also for many people the first time. It was at the Paris Electrical Exhibition in 1881 where they first experienced this, invented by an engineer called Clément Ader, who is a French engineer. And people said, it's remarkable kind of having these sounds, approaching you from all different sides at once. And it's also the first time they're even having kind of, let's say, acousmatic experience of sound where they're not seeing the sound source. They're not physically present in the theater. So it's quite an unfamiliar kind of, experience, and they're trying to find a language to describe these sensations. In any case, so that first stereo transmission system is quite old, 1880s. And then the binaural transmission, the first binaural, so let's say where the microphones would be placed, where the ears, let's say in a average size, quote unquote, human head, and there we have Oscar, the binaural dummy. That's happening in the 1920s and 1930s, and that actually comes out, I look at it from the perspective of a group of scientists who are developing this at Bell Telephone Laboratories, and before that, Western Electric, it was called. Harvey Fletcher, who's of course a very famous acoustician of the 20th century, who's running the acoustical research section at BTL, at Bell Telephone Laboratories. But he's actually first studying this kind of phenomenon and actually gets into acoustics for the first time during the First World War, because during that war, they're trying to find new methods of locating new technologies of offense, including the airplane, submarine, using sound and listening. And so Harvey Fletcher is, along with many other people, recruited to do wartime research for the U.S. military. They have the Signal Corps, which is the military body that oversees that kind of research. And then they, during the war, create the Signal Corps Reserves. So it's much, much, much bigger group of scientists, researchers, engineers, many of them, who are doing this kind of wartime study. He starts doing underwater science, submarine location using hydrophones, but to try to kind of locate submarines. But then he transposes that after that, those same principles into Oscar the Dummy Head, into doing binaural transmission of sounds. And then they also do stereo recording and reproduction at BTL.
And so Oscar was literally just like a tailor's mannequin dummy.
That's
that
it.
They like drilled some microphones into the sides of the head.
Yeah.
And so what's the sort of idea behind that versus stereo that they were trying to get?
Yeah, exactly. The idea, I guess, is to then mimic the sensations of audition that a human would have, and to be able to, let's say, transmit those more specialized sensations of spatial hearing to another listener. So they use Oscar the Dummy Head to do recordings, for example, of the Philadelphia Orchestra with Leopold Stokowski conducting, and they want to do maybe radio broadcasts and have people with their 2 telephone receivers hearing it in spatial audio. They don't quite get there, but then they do other experiments and demonstrations, and my chapter on BTL is almost about this kind of spectacular demonstration of stereophony that's happening in the 1930s with Bell Telephone Laboratories and their experiments. They're doing this for a very wide public, and they have Oscar the Dummy Head as part of a much larger exhibit at the 1933 Chicago World's Fair. And about 600,000 people actually experience a kind of show, the Oscar show, where people are saying things around the dummy head, which is on a stage. And people, again, they're sitting there with their two telephone receivers, almost like pseudo headphones. You know, that was
so in this,
headphones,
they've got Oscar on the stage and a show going on around him.
Yeah.
Exactly.
And they've got each person in the audience has their own set of like proto headphones sitting there. So they can all hear, they're all experiencing what Oscar, their sort of stand-in on the stage, would be experiencing.
That's right.
That's fantastic.
Yeah. And it was quite a sensation. It was one of the most popular exhibits at that fair, which was a big fair. And and probably for, again, many people, their first time feeling this, having this kind of sensation. And it was quite a wild kind of experiment. You know, people are stunned, and you know, they gasp, and they're not, you know, BTL is also doing experiments where they're doing 3-channel quote unquote stereo, let's say multi-channel transmission of live music from the Philadelphia Orchestra's auditorium where they practice to a massive auditorium in Washington, D.C. And but it's only being projected over 3 speakers. But those speakers first are hidden behind a curtain, then they lift the curtain, and the audience is shocked that the orchestra is not really there. So they're trying to also then communicate these, you know, ideas, demonstrate them to a big public. In effect, because I guess at the time they want to both improve sound quality over the telephone. That's, you know, the main purpose at AT&T and BTL, but also because they were thinking about going into the audio industry. They didn't quite do that, but that was part of the aim at the time.
I want to go back actually to the Philadelphia, Washington demonstration, because I've read about that somewhere else. I can't actually remember where, but just to sort of get it across, essentially they have the orchestra in Philadelphia.
That's right.
On the stage with like a microphone array in front of them, right?
Yeah.
Picking up all the different spatialness of the sound that they're producing.
That's right.
At the proscenium, right?
That's right.
And then they hook the wires from that up, run them to
using
Washington.
telephone wires. Using telephone wires. Yeah.
It's brilliant. Like, and
Still better than Wi-Fi, I guess.
it's still better than over the internet.
Better than Wi-Fi.
Yeah. And then they hook that
We've
up
gone
to
backwards,
like corresponding speakers in the proscenium in Washington behind the curtain.
That's what Fletcher called his 3-channel system. Exactly.
And it's like a ghost orchestra.
That's right.
For the people in Washington,
who are completely shocked when, you know, they're expecting to hear Leopold Stokowski conducting the Philadelphia Orchestra. Stokowski is also a very, very renowned conductor who is also quite a experimental conductor, very modernist kind of conductor, and he's doing many things in the acoustic domain as well. He does collaborations with sound engineers and radio engineers, and he tries to study acoustics and audio and in a much more, let's say, rigorous way than many conductors at the time. He's very pro-technology. He's also pro kind of, you know, he commissions Leon Theremin to create a theremin kind of cello, and then he wants to, or kind of I should say, an electric cello, and then he wants to commission a whole bank of these kinds of instruments for the Philadelphia Orchestra. He has his own ideas too about almost having these like sound gardens, he calls them, where people will, you know, go and have like leisure time, and you know, it's almost a bit of a fantasy about I describe it almost as a kind of socialist fantasy where people, you know, don't really need to work anymore, and they have these kind of sound gardens, and this is part of his, you know, vision. So he's quite an interesting conductor. People are going to this auditorium to hear him conduct, but there's just a curtain when the experiment starts, and they don't see anything, but they are hearing an orchestra, and they think it's in the room with them, and the curtain lifts, and there's nobody there. There's only these 3, I should say, enormous loudspeakers.
I guess, I mean, the frequency content must have been compromised somewhat. I mean, you would get the spatiality, of it, but just with, I mean, when we are comparing it with modern times.
No, you're right. But you know, when you look at the size of that speaker, they're trying their best. You know, it's
I'm just thinking about telephones.
Just for the imagery, the photo from the book is like these two, I guess, like 6-foot-ish men standing next to a speaker which is at their head, at their eye line.
That's
it's just absolutely this 5-foot tall speaker.
That's it.
Where are the tweeters?
But you're right, and they do study this, and they have a whole kind of journal of with various articles from different people in the acoustical research section team and other teams that were then studying things like frequency response, and they are also interested to know how does that also affect things like intelligibility, of course, for telephonic listening. That's a, big thing. And the sense of spatiality. And they have Stokowski as well as members of the orchestra then as almost participants in their experiments where they are testing, this, and they have to kind of tell them what are they hearing when they hear through the ears of Oscar, or what are they hearing through the 3-channel system. And according to their reports, it's quite good. Of course, maybe they're biased, but and they're also developing the system that they might commercialize one day. But it seemed pretty okay.
I think the expectation difference between what we have now, and we're all so used to having sound which is disconnected from the source, right? We all have, even now, wireless headphones which are completely disconnected from any sort of source, really. And that's very normal to us. I'd be curious to know, like, what would go through your head back then of you've never experienced that before. And then suddenly there's a phantom orchestra, like that's got to be a wild experience.
Virtual reality, it's immersive, basically.
That's right. It's a very unfamiliar experience, and when they demonstrate this kind of stereo reproduction, then when after they've figured out kind of how to do stereo recording and then reproduce it in a concert hall, which they do at Carnegie Hall in 1940. That's one of their big public demonstrations. My sense, reading what critics and audience members said, and also people who wrote to the people at BTL, about their experiments, you can find those, memos and letters at the BTL archives, was that it was, very unsettling, but also in my opinion, they must have been very loud because people, they said this woman, jumped out of her seat as though kicked by a horse, and
it
people were
loud,
and I think they were. I think they were quite loud.
There was no conscience about dBs that a speaker can produce at the time.
Probably not.
I mean, if you're sticking a 5-foot tall speaker on the stage,
well, you can play it
probably
quiet.
not that worried about it.
No, that's it.
So, did you guys have anything else?
No.
So at this point now, we've stepped through from sort of the first conception of, we should be studying stereo spatial sound, and how it comes from binocular studies, through to now the 1940s, 1950s, and how it was used in music, how it was used in art, and sort of was understood. What we're gonna end our episode here, and leave everyone listening on a cliffhanger. Because we're gonna come back in our next episode with Gascia again, and with her colleague Ruth, and we're gonna talk about how this sort of conception then came into cities, into studying cities, how studying sort of our spatial world as it is, and then how that has translated into their future work.
Great.
So thank you very much, Gascia, for joining us.
Thank you so much. It's been great. Thank you.
Thank you.
Thank
and
you.
We'll see you all in a bit.
Great.
And cut.
Pretty spot on, I think. 35 to 40. I thought you were going to talk more about warfare, though.
The rest is just noise.
You can find episodes of The Rest is Just Noise on all of your usual podcast apps.
And on our website at justnoisepod.com. We're also on Twitter as @justnoisepod.
The Rest is Just Noise is supported by the UK Acoustics Network.
Plus.